In today's lesson, we're going to review and practice graphing lines. One form that you may be given is the standard form of an equation, and that's where you have a times x plus b times y, and it equals c. And a and b and c are all numbers, but a and b specifically can be any real number except neither a nor b can equal 0. So c can be 0, but a and b cannot, and a, b, and c can be any real number. So we really want to remember that standard form. Okay? The example that we've been given is in standard form, where we have a times x, or a number, which is 2 in this case, plus b, which is negative 3 times y, equals c, which in our example is 12. Our very first step in order to graph this is to identify our intercepts. And so for step 1, we're going to actually find our x-intercept. X-intercepts are always located at some number, comma 0, and y is always 0 because that's the only way that we'll end up on the x-axis. So I want to replace or substitute 0 in for y. So I'm going to do that algebra now. 2x minus 3, instead of writing y, I've written 0, equals 12. And any number times 0 is just going to be 0, so I can eliminate that. And it makes my algebra really simple to just say I'm going to solve 2x equals 12, which is why whenever I'm given standard form, I want to graph by finding the intercepts. Because in a very short amount of time, I've already been able to identify one point, which is the x-intercept, and that's located at that's located at 6, 0. So I'm going to graph that. I'm going to go to the right 6 units and up 0. And you see that that point is lying on my x-axis, which is what makes it an x-intercept. Now we're going to go back. We're going to do step 2. Instead of finding the x-intercept like we did for step 1, for step 2, we're going to find the y-intercept. All y-intercepts are located to the right 0 and then up or down some number. That will land me always on the y-axis. So this time I want to substitute 0 in for x. And you'll see that my algebra is going to be very similar to step 1. When I substitute in 0 for x, that eliminates that whole first term. Now I need to simplify where negative 3y equals 12. I divide both sides by negative 3 and I get negative 4. So this tells me that the y-intercept is located at 0, negative 4. So I'm going to plot that. I'm going to go to the right or left 0 and down 4. I get my 2 points, and so I'm just going to connect those with a line, and that's my final step. Step 3 is to just draw a straight line through the 2 points. Hopefully your line is straighter than mine and you used a ruler. If we take a look, right, our x-intercept was right on our x-axis. And so an additional thing to remember is that all x-intercepts are always some number, 0. And in order to find the x-intercept, I'm going to always substitute 0 in for y and solve. My y-intercept was located on my y-axis. That's where my line crosses or intersects the y-axis. It's always at 0, comma, a number. And so I find my y-axis, I find my y-intercept always by substituting 0 in for x. So in summary, standard form is ax plus by equals c. And to graph an equation in standard form, I want to find and then graph the x and y intercepts. A different form, a form that many of us are familiar with, is slope-intercept form. It's that notorious y equals mx plus b. And so I definitely have to have that memorized. And m represents my slope. From a previous video, we learned that slope is how steep that line is. It's my change in y over my change in x. And then I also identify my b value, which is my y-intercept. And we just talked about how the y-intercept is always 0, comma, some number. In this case, it'll be whatever that b value is. So my first step in order to graph this given equation, which is the same equation that we just completed, but in order to graph it using slope-intercept form, I first have to solve for y. So I'm going to solve, where does 2x minus 3y equal 12? I'm going to solve that for y. So I want to move the entire 2x term over to the right, so I'm going to subtract that. I always put my term with the variables before my term that's a constant. And then I divide off that leading coefficient of y. And I get y equals, by simplifying, I get 2/3 x minus 4. Based on our slope-intercept form, that tells me that my slope, my value in front of x, is 2/3. And it tells you my b value is 0, comma, negative 4. So my y-intercept is 0, negative 4. That's my second step. My second step is just to identify those two main key components from my equation. And in some instances, step 1 will have already been done for you, and the problem or the equation that you're given will already be in slope-intercept form. In that case, your only step will be to find or identify the slope and the y-intercept from the equation. Last step is going to be to graph. So to graph an equation in slope-intercept form, I'm going to start by plotting the y-intercept. My y-intercept was 0, negative 4. So I'm going to go on my y-axis down 4 units and put a point. My next step is to then determine the next few points based on our slope. If my slope is 2/3, that means from that original point, my y-intercept or my b value, I want to count vertically up 2 units and then to the right horizontally 3 units. And when I get there, I'm going to put a point. Then I'm going to do it again, up 2 units and to the right 3 units. I'm going to continue doing this as many times as possible. I'm going to graph by connecting all my points with a perfectly straight line. If I notice my y-intercept, my b value, is located right where that line crosses the y-axis. And again, my slope, that second step, was how much I rose and then how much I went to the right, how much I increased versus how much I moved horizontally. That m value corresponds to my slope, so everything in blue, highlighted in blue, goes together. And my b value corresponds to my y-intercept. Everything highlighted in yellow corresponds to the y-intercept. If you notice, both of these graphs are identical, and that's because our equations were equivalent equations. It's just a matter of which form you're given and the easiest, most efficient way to graph based on that given form.